A quick recap of how we started, right? So this is our Titanic data set, right? This is a CSV file. It is actually saved at a GitHub location, and this is from where we are actually using it or loading it. How did we load it? pd.read underscore CSV, very simple. And this is the data frame basically that we are actually creating using Pandas, right? So quickly just look at it as right. So if you do not need to speak, then can you please mute yourself? Yeah. So what we are doing here, right? Let's quickly look at what are all the data points here, right? So we have a passenger ID, we have survived value 0 or 1, whether the passenger survived in that trip or not, passenger class, and then we have the rest of the fields, right? So name, sex, which is gender, age, uh, CBSP, we do not necessarily need to know what exactly it means. P arch is fine. Ticket number, fare, cabin number, and embarked. We really do not need to know specifics of all of these fields. So, but then this is how the data structure looks like, right? Now, what do we need to do today, right? Let's go down, and what I will do is I'll probably add a more new cell and actually try to print the data frame here so that we can actually refer to this, right? So this is our data frame. Now what we are going to learn today is when you actually write Titanic, right, which is our data frame, it prints the whole of the data frame. And then there are ways of doing dot head, dot tail, which gives you the top five or the bottom five rows from the data frame. But how about if there is a requirement where you just need to uh, fetch name and age? How do we do that? Or name, sex, and age. If that is the requirement, then what we can do is we can specify the list of the fields inside a list. And this is what we need to do. So there are two ways you can do this, right? You can specify my columns is equal to, and then specify this inside a list, right? And then just say my columns. So if you do this, then what is happening here is you are only pulling out these columns, which are inside my calls from the data frame. So data frame is Titanic, and what is it that you're passing? My columns, and my columns is nothing but a list. And what does the list contain? The list contain, uh, all the names of the columns, right? And that is what we are interested in. Let's say we only need to fetch name and age, then we can just modify this. So there are two ways you can do this. Either you can specify this separately, right, inside a variable. So this is one way. The other way is you can just put this list inside this bracket. So what do you observe here, right? There are two opening and closing brackets here, right? Now, what does this signify? That name and age is a list. So the column names that you need to specify here should be stored as a list, and that is what is important, right? So I hope you are getting that distinction and not getting confused as to why we are putting double brackets here, right? So double opening brackets, double closing brackets. The first one, which is this one, which is ending here, is for the data frame Titanic, and this one, which is inside, is a list which is actually encompassing all of these field names. Now, one thing that you can also do here is, let's say if you have a need where you want to rearrange them, then you can do that as well. That is totally fine. You do not need to specify them in any specific order. You can give them, you can specify them in any order of your liking or need, howsoever you want this. Right? So this is one way of how to filter out specific columns. So what we were trying to do here, we were trying to filter or fetch specific columns. Now we will see how do we fetch specific rows. right? Specific rows of records. And then we will move into how do we do both of these together, where we not just filter out specific columns, but also specific rows. So for columns, you just need to specify the column names inside a list, and that is done. Now, what can we do for rows? Now the thing is that the rows, when you look at the data frame, right? This is our data frame. The rows have indexes 0, 1, 2, 3, 4. It does not have names. Columns do, they do have names, but then the rows, they do have index numbers. They don't have row names, right? Or or anything like a text. So what we need to do here is we need to specify the range, right? So the function or the command that we are going to use here is ilog, right? And you don't need to actually bother about this new command. Ilog simply means I means integer, and loc is the short form of location. So ilog would mean integer location. So what is it that we are trying to specify? From Titanic data frame, give me integer locations 0 to 5. Now what does it mean? It means that give me all the rows which have a integer number, or in the row number starting from 0 to 5. And we already know that indexes in Python start from 0, and whatever you specify as a second parameter, that number is excluded. So basically this is going to give you 0 to 4, all the rows with indexes 0 to 4. And this is what is happening here. If you look at it, it is giving you, let me run this again. So it is going to give you 0, 1, 2, 3, and 4. You can change it to 0 to 11. So it is going to give you 0 to 10. You can change it to 0 to 3, and this is going to give you 0, 1, and 2. So this is how you actually select specific rows. Now let me do one thing. Let me put in specific comments here, filtering rows of data, right? So that you can actually know. Right, the same way, what we are trying to do is filtering columns of data. Right, so this is where we are filtering columns, and this is where we are trying to filter the rows. Now, can you change this to, let's say, oh wait, can you change this to, let's say, do we necessarily need to start from 0? Not necessarily. If you need to, let's say, start from row number 51 to 60, then I will specify 51 to 61, because 61 will get excluded, and you can actually do this way as well, right? So this is going to be how you can use it, right? So what I will do is I will actually create another cell, and this is where you can actually select 51 to 61, and here we can just leave it as 0 to 5, the default one, where we start from 0. So very simple. This is if you really need to filter on rows, you just need to specify ilog and the index numbers. So for columns, you need to remember that the list that you need to provide should have all the column names. For rows, we have to use ilog, and then you have to specify the integer locations for the rows. And that is how you select the rows. So the question may now arise that do we need to know the column names? And is there a way where we can actually select these columns by specifying their integer locations without specifying their column names? So the answer is yes. Yes, you can do that. And how you can do that? You just, if you look at the data frame, right, you can just start counting from the left side to the right side and just keep giving these columns their column numbers, right? So passenger ID will become index 0, column index 0, Survived will become column index 1. P class will become column index number 2, and likewise. Same way 3, 4, and 5. So age will become 5, and then the last one will be 6, 7, 8, 9, 10, 11. So embarked will have an index number of 11. But then here we are referring to column index and not a row index. So let's see how we can actually use index numbers for columns as well. Otherwise, if you are familiar and if you are, you know, if it is easy for you to work with the column names, then you can always use column names as well. That is totally fine. So, so we have done this, right? We have done this filtering rows. Now we can do filtering rows and columns of data. So basically what we are trying to do now is we are trying to do both of these together. So look at this outcome first, right? What is happening? If you look at the number of rows, right? It is starting from 0 to 4, right? It is 0 to 4. So which exactly means that we are fetching the first 5 rows. But look at the columns. Now we do not see all of these columns, right? This is our whole data set. Passenger ID to embarked. But here we are only getting 0, 1, 2, 3, and 4. Just 5 of these columns. And that too starting from the left side, right? So what is happening here? Now we are using the same command or the same iloc command that we used earlier. But then if you look at it, now we have two numbers specified separated by or two ranges specified separated by a comma. So the first one that we are specifying here is for the rows, and the second range that we are specifying here is for the columns. And this is how you can actually filter out rows and columns together using their index numbers. So let's just find out if this is working fine or not, right? So is my row number correct? Yes, my row numbers are correct. But then here you will not see the rows numbers or the columns. You will always see their column headers. So let's check passenger ID, survived, P class, name, and sex, right? These are the 5 columns from the left with number 0 to 4, and this is what is getting printed. So this is going to be very easy, guys. You just need to specify the column, the row range first, and then the column row range afterwards, separated by a comma. And then you always have a choice, right? So if this is one command that you have used where everything starts from 0, you can always have 11 to 21. So give me 11 to 20th row, and you need to specify, let's say, only name and age, right? Or let's say name and age, name, sex, and age, right? So 0, 1, 2, 3, 4, 5. So 3, 4, 5. For 3, 4, 5 we will need to specify 3 to 6. So see what is happening. I wanted 11th to 20th record, so I specified 11 to 21. These are my rows, and I only wanted 3, 4, and 5. These fields, right? Name, sex, and age, and this is what we are getting. So if you really want to uh, filter out specific rows and columns together, you can continue to use iloc, where you need to specify two ranges. The first one is going to be for row, and the second range is going to be for the column, and you can do this.
But by this way, we cannot rearrange the column, right?
No, you cannot. You will not be able to rearrange. Yeah, you'll not be able to rearrange. It will always need to be left to right. Yes. If you need to rearrange, then you have this option
And
where
to
you can
get the
actually,
all column, we need to describe the data frame, right?
sorry, for doing what?
Get the all the column name list.
Hmm.
We just need to describe that data frame, right?
So describe will give you a lot many things which you may not be interested in. So I'll just show you, right? So this is my Titanic data frame. And when you do describe, then this is definitely not going to give you what you're looking for. It is only going to give you, for all the numerical columns, these measures, right? Count, mean, standard deviation, minimum, maximum, and then these percentile values. So this is not going to give you this. Uh, there's another function.
Okay.
Yeah. So you can use this.
Okay.
You can use
Columns.
this to get the list of all the columns, right? This is
Okay.
the property. It gives you a list as all the columns, right? And this is in form of a list, right? So you
Right.
can
Use for
again,
loop and we can get that list.
yes, yes.
Okay.
See, when you do a 0, then this is going to give you passenger ID. When you do a 1, then this is going to give you survived. But when you just print this, then this is going to give you the whole list, right? So this
Yeah.
is what you can do. Yeah, right. So, okay. So moving on, right? Now we figured out how to filter, right? There are other specific functions to filter out specific uh, rows, right, and columns of records. And how do we do that? There's a function called isNull, right? Now, one of the biggest challenges in data handling or data manipulation is when you get the data or when you load the data in a data frame, lots of data values may be missing, right? Or is not available. Something that we call as null or not available or not a number. So how do we actually first find those values out? Because the first thing that you'll need, what you need to do is, before doing any analysis on the numbers, you'll need to correct the data or you'll need to fill in those values. But then before you fill in those values, you'll need to first find out how to actually find those values out, right? Because from these many columns, 12 columns and 156 rows, it will be very difficult for you to actually look at them manually, one row each at a time, and then figure those out, right? So what you can do is you can use this ready-made function which is called isNull. And what does it do? IsNull is going to print you true for all the null values, otherwise it is going to give you false. So false is okay, because what it means is the value is not is available, right? If the value is false, the question is null. So it is only going to give you true when the value is not available, right? And it is going to give you false when the value is available. So value is available will give you false, which is good news for us. It is not a problem. And a value true is a problem because the value is not available. So let's see. As per this, my first record cabin, third record cabin, and fifth record cabin, these are not available. Let me check it. So when you look at the data frame, where did we print it, right? So see, my first record, third record, and fifth record. The cabin values are not available. And this is what it is showing me perfectly when I do the is null function, when I call the is null function. So this is going to return me true in all the places, right? So this is how you can actually find the null values. Okay, let's do something more specific. So now that we know that cabin has some null values, right? So what we can do, see, we can look at this column specifically by not just specifying the whole Titanic data set or data frame. We can specify cabin in here and then is null. And then what we can do, we can further count them, but then count is going to give you the all the count. This is not going to give you just the, what does sum do? So basically what it is doing now is when you do a sum, then it is going to give you a value 125. Now what do you interpret out of this? So it is going to give you 0 and 1, right? So 1 is true and 0 is going to be false, right? So if it is giving you 125, then what does it mean? Anybody?
125 are the null values.
Yes, this is what it means. It has lots of null values. So it has 125 null values, and then the rest are valid values. So out of 156 rows, 125 rows do not have values in them for kbin. This is what it means. So you can now try and combine these, right? We have already seen is null. We have already seen how to specify a specific column for the data set. And then when you do a sum, then actually this is going to give you a sum, right? For all the values, right? One would be true will be one, false will be zero. And just try to also look at count, right? When you look at count, why is it giving you 156? Because whether the value is 0 or 1, if you count them, it is only going to be the same as the total number of rows, right? And that is why it is going to give you 156. So this is not something which is unexplainable. This is pretty much explainable. Why is it giving you 156? You can do max and min as well, right? Let's do max, right? It should give you 1 or true, and when you do a min, then it should give you 0, which is nothing but false, right?
So please, like you use is null function then min function. So can we continue to add more functions?
You can, but then they need to make some logical sense, right?
Right, right.
Yeah, you can do that. Think of it this way, right?
So is just working like first it work is null, then it's for the minimum, and then if like another function we are using, then it works for this, right?
I'll let you know. Don't worry. I'll let you know. I'll help you understand as to what all you can do and what all you cannot do, right? So think of it this way, right? Whatever is the outcome of what you have on the left side of dot, that should become input for whatever is there on the right side of the dot, right? So for is null, what you need a data frame, a full data frame or a column or specific columns of the data frame. So that is why this is working fine, right? Now, what do you get? What do you get? What do you
Uh,
get as an outcome? Now you're getting as an outcome, what you're getting is one column of records, right? Which has 155 or 156 rows and one column, right? So whatever you can do with 156 rows and one column of records, all of this is going to be available for you to use here. Can I do a head? Yes, you can do a head because 156 rows and one column is in a sense what? A data frame itself. So data frame for with a data frame, can we use a head? Yes, we can use a head. Can we use a tail? Yes, we can use a tail, right? It is giving me the last five. So why will be it a problem when we do a sum? It will not be a problem. So you'll need to think logically, and that is how you can build. Now, if you want, can I use head now? Maybe it will not make sense because for head, what you need on the left side,
it
yeah, on the left side, you need a outcome, which is a data frame. But are you getting a data frame as an outcome? No.
just getting the value.
Yes. But can I now do a power 2?
Yes.
I can, right? So you need to think yourself as to what is allowed and what is not. Whatever is
Yeah,
the
this will
outcome, yeah.
make the logical sense that it will work, right?
Sorry?
It will make some logical sense, then it will work as you can use multiple functions with
Yes,
the dot.
yes, yes. And this is where Python is very powerful, right? You can actually write very concise or very compact code, but then you will need to actually be very mindful that what is it that this function or this command is giving you, right, as an outcome. So since it is giving me a number, then whatever you can do with a number is all allowed here. Whatever you cannot do with a number is not allowed. So if
Correct.
I say is greater than 100, that is also going to be true. I'm doing a comparison. If this number is greater than 100, right? So all of this are going to be possible, right? Okay. So now that we know how to identify or how to count, right? What are we trying to do? This is very simple. Count the number
Not
of
null value.
uh, n-
Not null
this is
value.
null value. This is null value,
Ah, is null, right.
right? So count the number of null values. This is what we are trying to do. Now, okay, now that we know that these are the null values, right? What do we do? We will need to treat them, right? So there are a couple of ways to treat them, and I'll tell you how to do that. The first one is a very simple command called drop na, right? And now what does it do? It drops all the records which has na in them, right? So wherever it has a null value, it will just drop the record. And how does it do it? It looks at row wise. So it look at the first row. If there is any record which has a null value or any column which has a null value, it will just drop the row itself. It will just drop the whole record. So if you look at it, see what is happening. We have a total of 156 records, but after drop in a, we are left with, I don't know, it is definitely not more than 25 to 30 records, right? It is only, and later on when we are doing the shape, then we exactly know that it is only 27 records. So when we do the drop in a, what is happening is around 125 records are being dropped. They are being dropped because they had null values, and the mostly the culprit is the cabin column. So
Right.
see, we have already seen that, right? The 0, 2, and 4, all of these are having null values. So are these getting dropped, 0, 2, and 4? Let's see. There is no 0 index here, there is no 2 index here, and there is no 4 index here, which means all of these values are getting dropped because the cabin value is incorrect, is null,
Null.
right? So does it make sense to actually see as to what is happening here? Yeah.
Yes.
So 157 records, right? 125 of them got dropped. So what we are left with is 27, right? So it makes perfect sense. How did we do this? So after drop in a, we can just use shape, right? And this is again something on the same lines, something that we did earlier with dot sum, right? Now with drop in a, we are using dot shape and seeing how what is the number of records, or what is the number of rows and columns after dropping the NA values. So this is one of the approaches where we can actually do this. The other approach is so drop NA. How is drop NA deleting the records? It is looking row wise, right? It is looking row wise. Now what we can do is when you look at this command here, right? We are specifying axis is equal to 1, right? So let's look at this a little more closely and see what is happening here. So it says the syntax says axis is equal to 0 is by default, right? And when you look at it, it says 0 or index, right? And 1 or columns. So these are the two values that you can specify for axis. Either you specify 0 for row and 1 for column. But if you do not specify any value, the default is 0, which means it will take rows by default. So why I'm showing you this is because in the earlier command drop in, we did not specify anything, right? Axis is equal to 0 or 1. We did not specify anything. So by default, it is taking axis is equal to 0. So either I write drop NA and I do not specify anything here, or we specify axis is equal to 0. Both are going to be the same, right? Because axis is equal to 0 is the default value. But what is happening here is, let me just not write it here. What is happening here is now I'm specifying axis is equal to 1, which means that I want to instruct Python that you delete the NA values, but look at columns instead of rows. Any column which has NA value, delete them, right? So the reference is now going to change. Any column which has even one in a value will get dropped, right? So what is guaranteed here is you're only going to see columns which has no null values, right? So let's see, do we have that cabin column here? No, there is no cabin column here. But we do have survived, we have passenger ID, which means for all of these columns, there are no null values. Every possible value is a valid value. Every value that is there in these columns are valid values, and that is why these columns are not dropped. So axis is equal to 1 will drop looking at the columns for null values. Correct? Got it? So moving on. So these are the two ways, right? You can actually drop. But if you look at the strategies, right, and we can probably talk about some of the strategies, right? So how do you handle null values? Ways of handling null values. So there are a few strategies, right? The first one is delete or drop null rows or columns. So this is what we have already seen. This is one of the strategies. Either you delete or drop such rows or columns that have null values. That is one. The second one is called imputation. And imputation is nothing but, you can also refer this as fill values, right? Which means in the first strategy we were trying to delete the rows, right? But and because of which my number of rows and columns were getting affected, right? But what if you do not want to do that? This is not the best of the strategies. This is definitely not one of the best of the strategies. Why? Because you lose data. There is loss of data. And at times, if you're working with a small data set, then you cannot afford to lose data further, right? The data set that we are working with has only 156 rows and 12 columns. And if we are restricted to, instead of 156 rows, if we are restricted to just 27 rows, right? After doing a drop in it, then we are left with absolutely nothing, right? To do our analysis, we are only left with 20% of the data. We are losing 80% of the data when we use this strategy, drop in a. So this is usually not followed because it limits the data which you have available even further, right? So this is not one of the best strategies. So what do we do? Imputation or fill values, right? So what do? We try to fill in, instead of deleting the values, we impute or replace the values, right? Or replace null values. Now you must be wondering, if you do not have the values available, then what is it that you replace it with, right? What is it that you can replace this with? So there are a few strategies here, right? You can replace it with any constant value, right? If it makes sense, you can replace with a constant value. The other thing that you can do is you can replace with central tendencies, right? Central tendencies. And we have already seen what are the central tendencies we have. We have what? Average or mean,
Average mean or
right?
standard deviation.
Yeah, so that is one thing that you can do. And that's something that we can try, right? There are other ways of imputation as well, and we will actually not go much detail into this because these are part of the strategies, right? What we should actually focus on in whatever strategy you take, how do you actually implement this, right? So let's first look at how to impute using a constant value. So see what is happening here. Instead of drop in a, now we are following or using another function called fill in a. right? And what is fill NA doing? We have specified a number, right? So what is it that we're trying to do? We're trying to implement this strategy. Fill values with a constant value. Okay, it's a different discussion altogether whether filling it with 100 makes sense or not, right? It's a different discussion altogether. What we're trying to do is, if it makes sense to replace all the missing values with 100, then how do we do this? So right now we are trying to fill NA with 100, right? And when we do this, see the outcome. First, look at the outcome. There is no change in the number of records. There is no change in the number of rows. There is no change in the number of columns, right? So my rows and columns are intact. I'm not losing any data. So that is the first thing that you need to understand here, which is different from drop NA, right? So fill NA, we are not losing any data. That's the benefit. The other thing is, if you look at these values, right? Remember those rows for cabin 0, 2, and 4, which were not available? All of these values are now 100. Even the last four values, if you see, these are all 100. So how is this happening? Because now we are using a fill in a function and we want to update these missing values with a constant, right? So that is one approach. Now you must be wondering, okay, this is a definite given that 100 does not make any sense here. We just picked a random value with which we wanted to replace this. The 100 definitely does not mean anything here. So what are the other options, right? What are the other options that we have? Like I told you, central tendency, average or mean is one of the options. What you can also try and do is mode. What is the most frequently occurring value? This is what mode gives you. An average, you already know. Add the numbers uh, and then divide it by the number of samples, right? So you can follow either of these. Both of these are going to give you the central tendency. Now, so what we can do is we can apply either of these. So let's see what we can do here. So 100 definitely does not make sense here because it's a cabin number, right? It's a cabin number. And cabin number, if you look at these legit values, they are C85, C123, C2, right? So what we could have done instead of 100 is we could have specified something like A10 or something like that, right? So you can specify a text or you can even specify a number. Whatever you specify, this is going to just replace everywhere, right? So this is going to be like this. But what is happening here is maybe, what we can do is we can specify a mode here, right? Instead of a constant value, or you can specify a max or a min or an average. Since these are not numerical values, right? Average will not make more sense here, but we can definitely look into doing a mode here, right? And mode is what? We already seen this earlier in our last class. Mode gives you the most frequently occurring number, right? So
Yeah,
if,
most number.
yeah, the number which is occurring most number of times, right? Or the value which is occurring the most number of times. So Kbin value which is occurring the most number of times is what we want to replace the nulls with, and this is what we are trying to do. So how do we do this? Of course, if you look at the function now, this is much simpler, right? Titanic cabin, and we want to fill the null values inside the cabin field. What do you want to convert or replace this with? That is what we need to specify inside the brackets, right?
Right.
What will this give you?
The mode of the values of the cabin.
The mode of the values of the cabin, right? Which is going to be which cabin is most frequently occurring in this column, right?
Yeah.
So what we need to do is we just need to specify this inside the brackets, right? If it
Yeah.
sounds a little, or if it looks a little difficult to interpret, then you can break this into two lines. That is totally fine. new cabin value is equal to Titanic cabin dot mode. So I get the mode of Titanic cabin column, and then we can specify new cabin value. This is also fine. It is going to be no problem. So what we should first do is first look at it. What is the
More value.
mode value?
So more value is nan. No.
Yes. So this is the problem. This is the problem. So getting the problem.
Yeah.
There are more nan values. There are more nan values than legit values. So this
Right.
is where the problem lies. It will also count the nan values, right? And actually, it
Can
will
we ignore the nan and then we can find out the mode?
no, it will not ignore that one. So in this case, when you try to do the mode, then it is actually going to be of no use.
Maybe.
It is going to be of no use because what is happening here is that you're replacing null with null, and then it is going to be of no use. So this is actually not a good example actually, right? So we can, what you can also do is you can try on your own, pick another column, and I can actually help you figure out that column, right? So what you can do is uh, parch parch drop na s- survived p class. Okay, so fair also has a value embarked. So we can probably do it for embarked. So let's do this for embarked. Let's see what happens. So embarked has a value of s, right? So this is what we can do. And then we can specify. Oh, wait.
Manish, can you please repeat last 2 3 minutes?
Yeah, sure, definitely. So what is happening here is that we were trying to replace or trying to implement this this one. We were trying to impute the value using
Yeah.
mode, right? This is what we were trying to do. So we had taken an example of the cabin column, which is actually not a very good example because most of the values there was null, right?
Right.
So mode was coming out to be null, and that is not what we wanted. We wanted mode to give us a non-null value. So we are
So now we are picking another column.
yeah, so we are checking another column embarked. More cabin is not a good example to implement imputation using this strategy using mode. So, and this is what you'll run into your, in real life as well. When you try to implement this concept, every time you will be faced with specific columns, which will, require you to implement different strategies into different columns. Not one strategy suits all the requirements. So now what is happening is we have printed the new embarked value, which is nothing but the mode of embarked, and we are getting a S. And then when we are filling NA with the new embarked value, then wherever you had null is getting replaced with S. And this is what is happening here, right?
Right.
So this is one of these fields, right? Now in this example, we do not have any numeric field which has any null values. But if that was the case, then you could have used average and mean. So the difference between these two would be can be applied on numeric fields, right? And here this could be applied on any field actually. This could be numeric or non-numeric. This could be applied anywhere.
Yeah, but I guess for the numeric value, mode is not much more used, right?
Yes, it totally depends, right? So let's say there is a shoe size field, right? Shoe size, right? Now that's a number, definitely. But then you usually do not calculate an average, right?
Mm. Right.
7.25 would not make any sense. So if the value is ordinal, then in that case, or categorical, even if there is a number, but then the number has a categorical sense, then you would want to actually use mode for
Right.
numbers than averages or means. All right, so moving on, right? So what we need to do here, we are trying to, and this is something that Gajendra, you had just asked like 5 minutes back, right? How do we filter specific on specific values? So let's say what we were doing earlier, right? We were only looking at specific columns. But what if I want to only find out any specific values or filter out specific values from that column? So I want to look at all the records which has a sex value of male. How do we do
Mm.
this? So inside the brackets, inside the big brackets, you can specify Titanic sex is equal to male. This is totally fine. So you can do this. And when you do this, this is going to give you all the records which has a sex of male,
Mail.
right? You can change it to female and then you can see that you have, yeah, these records with this value as female. So I'm just leaving it
So, like
like this.
earlier, I asked you that if we can ignore the nan value here, so we can just not equal to nan and
You can
find
do
out
that.
the mode,
You can do that
right?
as well. Yeah, you can do that as well. Yeah. So that is how you actually filter on specific values within the column. Earlier we were only filtering the whole column, right? Specific columns, but now you can filter on any specific values. So since this is a text field, you could actually do a comparison using text values. If it is a numeric field, then you can actually do a number comparison as well, right? So give me all the records which has a age value of greater than 50, and this is what is being returned here, right? So all of these age values are more than 50, right? So these are the two ways, right? String comparison is equal to, and then specify this inside either single quotes or double quotes. The choice is yours, but then you can do a number comparison as well. Okay, what if I want to look at all the records with age between 25 and 50, right? Then in that case, you'll need to specify this two times, right? Greater than 25 and then less than 50. So this is going to be between 25 and 50, and you can separate this with and. So what it means is you can do and comparisons or and you can use and operators as well if you need to specify multiple uh, multiple statements, comparison statements, right? And I'll give you another example so that you know, right? So here all the age values will be greater than 25 but less than 50. So look at all of these age values. Do you see anything less than 25 or greater than 50? No. Every value is between 25 and 50. So if I were to ask you, what do I do to only find out the males below or males uh, greater than 60 years of age? How do I do that? So for that,
Sorry, what's your problem?
all the males, right? All the male passengers with age greater than 60,
Yeah, so we can pass the sex is equal to male.
right? So the first one is okay, right? So let me do this. Sex is equal to
Male. And
male, right? And age.
Greater than 60.
Greater than 60, right? See, specific records. People with sex is equal to male and age greater than 60, right? So all of these are correct. So you can actually blend these as well, right? You can add as many criterias as you want, right?
So we just passing the where condition as we pass in a civil.
Yeah, so this is like a where clause itself. Yeah, this is like a where clause where sex is equal to male and age greater than 60. So
Okay.
basically, what do you do when you specify a where clause, right? You do specific filtering, and that is what we are trying to do here as well. We are doing specifics, I mean filtering on specific columns,
Columns, right?
right? Okay. So this is fairly simple, right? If you add another field, survived is equal to 1, then this is absolutely going to give you no records. Because if you look at these survived fields, no one survived, right? No male greater than 60 survived, right? Okay. Interestingly, if you want to do a count, you can definitely do a count, but you will need to find out what is happening here, right? So it is returning you a data frame. So you cannot straight away do a count, right? You will need to first convert it into a manner where it gives you a one column and then you can do a count, right? So see, this did not make a logical sense for me to do this, and actually it is giving you passenger ID 4, survived 4, P class 4, name 4, right? So it does not make a lot of sense. Okay, all right. Now moving on, right? So this is going to be very useful, guys. I mean, the way you can actually filter on specific values of the column.
So many on data frame we cannot use count and all, right?
You can use count, right? But then where do we use count? When you do a describe, count is actually used to count the values and actually see what is happening. I'm not saying that this is not correct. What I'm saying is this is not going to be of any use, right? When you do count, what is count doing? It is counting all the passenger IDs, it is counting all the survived, it is counting all the
Right. So
P classes.
basically, we will count every column values, right?
Yes, but then for cabin, see, there are two nan values. So for cabin, it is giving you 2, and for the rest of the columns, it is giving you 4,
Oh,
right? So what I'm saying
okay.
is maybe it does not make a lot of sense to use count here. That is the only thing which I'm saying. You can still use it. It is not going to give you any syntactical error or something, but then maybe it is not
So
going
how
to.
we will get the row count in the data frame?
Sorry.
How we will get the row count in the data frame?
How do you get the row count, right? Okay, so for that you can do a shape or size, right? You can do a shape. So it is going to give you 4 and 12, so number of rows and columns. And if you want to just see the rows, then specify shape 0 and you get the number of rows,
Right.
right? So what I will do is, since you are asking about it, I'm putting this as a separate command here,
Yeah.
but I'm just leaving this one as is so that
You
you
just
can.
put small header as well as the row count for data frame.
Yeah, sure.
Thank you.
No problem. Number of rows. So print the number of rows of the data frame. Okay. All right. So this is what it is giving you. The okay. Now, quickly. So sort values, right? This so we are kind of getting closer to the end of this, right? So sort values, right? W- Again, if you are trying to make a SQL comparison, you are maybe thinking on this, thinking on the correct lines. What does sort values do? So in SQL also we can do ascending and descending sorting, right? If you want to sort on specific fields, then you can do that as well. What are we trying to do? We are trying to sort values on the age, right? So it is going to give you, see, all of these age values are actually sorted. Is 0.82, 2, and then 3. So you can specify any. Ideally, it is advised to use any numerical field here. It will not make any sense to do a sorting on it will actually, right? It will. If you do sort on name, then of course this is going to be alphabetical as well. So this is also having some relevance. I'm not saying that this is going to be absurd. This is also going to be equally important, but then primarily you'd want to sort based on a numerical field. So see what is happening here. Ascending is equal to true, right? Is the default sort order. And if you want to sort on descending order, then you just need to specify this parameter, right? Why I'm showing you this way, so that you guys also get into a habit of actually trying to explore more, right? So the very first question that should have come to your mind is we are sorting, right? And then mostly either sorting on age or name gives you ascending order, right? How do we do a descending order sort? So for
We
that,
just do
you
false.
just need to specify ascending is equal to false,
False.
because ascending is equal to true is the default sorting order. So you can do this as well. So let me put this as a separate command, and the first one was, which I'll leave this as is. So sort by age, this is ascending, and the next one is sort by name, descending, right? C, Z, W, followed by A at the very end. So this is again very simple sort values. Hmm. Okay. Now, can we sort can we sort on multiple fields? So there are these examples, right, where what can happen is the two of the values may be the same, right? So in that case, what you can do is you can specify a secondary field as well. So what I'm trying to primarily do is I'm trying to sort on my age field in an ascending manner, but then my secondary sorting should be on P class. So if my age values are same, then it should secondarily sort on my P class value. But if you look at this, all of these values are also turning out to be the same, right? P class is also 3 for them. So actually, there is not going to be any impact here, but then the thing to learn here is that you can specify multiple columns, and whenever you specify multiple columns, we have already learned that we always need to specify that as a list. So what is happening, my age becomes the primary column for sorting, and P class becomes the secondary column for sorting, and that way we can actually sort multiple based on multiple columns. So that is it for multiple column sorting. Now, one interesting thing that you should definitely learn is at times what happens is you do a lot of data manipulation, and then you want the output of all of this into a file, right? So remember, it all started from a CSV file, right? We have started loading the data from a CSV file, right? And we have done some manipulation. Let's say after the sorting, we want all of these values to be thrown out inside a CSV file. Can we do that or can we not? The output is going to be very simple. The command is going to be very simple, right? This command is giving you the sorted values for age and P class. Now you can just specify dot to CSV instead of a from CSV. You are specifying to CSV, and then you specify the name of the file. And then what this is going to do, this is going to create a out.csv file, and this is where your outcome is going to go. And that is why when I'm running this command, I'm not getting any output, right? Because the output of this, which is this data frame, is going to the out.csv file. So where will I get this? See, this is the file which got just created, out.csv. And when I open this, what should I expect? I should expect that this is sorted on age and then P class. So let's see. Is it sorted on age? Yes, it is sorted on age, right? The age values are increasing as I go down the file, and these are the null values. And for any specific, let's say these three records, right? These three records. Is it secondarily sorted on P class? Yes. P class 2 first appears first, followed by P class values 3. So this is working fine. The new thing that we have learned is the 2 CSV function. The 2 CSV function, right? You can do a 2 CSV. You can also do, I'll just show you. The way you have from CSV and from Excel, you also have 2 CSV, and you can also do a 2 Excel. So when you do that, again, this is not going to give you any output. It is going to generate a file for you here. See, this is an Excel file. It's got just got generated, right? 21.9. And again, the outcome is definitely not going to be different. What we will have is again the same outcome, but the file format is going to be Excel this time, .xls. The records are going to be exactly the same, right? Okay, so we now also know how to generate output of our data frame inside a file, which is a CSV file or a XLS file. So with this, guys, we're pretty much done with what we needed to cover in Pandas. I know this was pretty lengthy. We already spent like 1.5 hours last time and almost did 1 hour today. So it was pretty lengthy. And the next one, which is going to be uh, the NumPy, is not going to be this lengthy. Probably we'll be able to finish it in one class. But do let me know if you have any questions in Pandas right now.
Not yet, Manish, but we do some assignment on that, then definitely we'll get some
Yeah,
questions.
sure. I will. Right. So in this case, what is more important for you to do is there's not going to be specific assignments on Pandas. What you can do is from your liking, from your understanding, whatever data set you find over the internet or which you already have or any project that you're working on, just pick that data set or pick any data set from Kaggle, right? And just start exploring it on your own and try to apply as to what would you want to. So let's say if you need to filter out a column, then apply yourself as to which commands you will need to use. If you need to, let's say, filter on specific column values, then start implementing it on your own, right? There is not going to be a specific assignment on this. And the first thing that you should definitely do is try to run through this top to down, right? You do not have a file dependency since this is a public location. You can just run through this top to down and see it yourself as to how the different commands are being used and how you are actually running this and what is the outcome. But trust me, to be able to practice on pandas, the best thing is to just pick any data set and try to do the same set of commands or run the same set of commands top to down there. So do your head and see how it is working, tail and do see what is how is it working. Change these values, change these parameters from 15 and 5 to whatever you think you want to change it to, and try to use them in tandem. Use shape, use info. What is more important is for you to actually practice them. It is not going to be uh, a programming problem that I can give you that you would want to solve, right? Exploratory data analysis is what pandas is primarily being used for, and for that you need to practice with unknown data sets, right? So practice with unknown data sets and just run these commands on the same on the new data set that you'll encounter, and this is going to be easy for you. So do these and do share with me your observations, whatever you come across, or if you have any questions, we can definitely look into solving them together. And for now, since we have around 15-20 minutes left, what we can do is do a small topic on date class in Python. This is definitely not going to be more than 15 minutes, and we can wrap this up as well. This is something which is outstanding from our previous class. So date class in Python, right? How do we handle dates? So we have libraries and then we have functions inside Python that we can actually use to work with dates, right? And these are very specific and targeted classes, right? The first one, the first library that we are going to look at is date time. The name of the library itself is date time. The class that we are importing here is named date, right? So how do we import date from datetime import date? This is how we import the date class. Now, what are we trying to do here? We are trying to create a date, right? And how do we create a date? We call the date function, right? We have already imported date. We are calling the date function, and then we have to specify the parameters, right? What are the parameters for the date? The first value is supposed to be the year
Year,
value, then the
month,
month value, and then the date
date.
value, right? And primarily, I mean, depending on what are you trying to, which language you are trying to build the date into, the syntax may be a little different, but then the idea is going to be exactly mostly the same, right? Where you will need to specify these three parameters, right? You cannot have a date without a day, a month, and a year, right? And this is very basic, and that is what we are trying to do. And we're just printing this, right? So we have built a date with we can probably change it to, or let's just leave it, right? So 2020 September 6th, right? And then we are just printing the date, right? And this is what it is printing. So this is how you build a date. Now there are a few things which are important for you to take a note of, right? Now these values, they have to be valid, right? They cannot be out of the range, right? What do I mean when I say these values cannot be out of the range? See, I'm trying to build a date with year 1996, month as 12, and day as 39. And we all know that this value cannot be more than 31, right? Uh, so it is going to give you an error. Day is out of range for month. And this is because I have specified 39. If it was 31, it would have just worked. So I just purposely left this as an error so that you know that these are not possible, right? Same ways, if you specify a year value as a string, then that is also not possible. A year cannot be a string. A year has to be a value, right? So there are two things which are important. All of these values need to be in range. They cannot be out of range. The other thing is an integer is required for all the three parameters. You cannot specify a string, right? Sorry, you cannot specify a string. Yes, you cannot specify a string. A integer value is required, right? So this is also going to give you an error, and I purposely wrote this, and I am just leaving it here so that this is going to be a reminder for you. So this is how you build date, guys. If your values are in range, then this is going to be the only command. Date and specify the parameters of the date. Simple. Now from date time, we are again so we are again importing date, right? And what are we trying to do? We are trying to use a function called today, right? And what does it do? Suppose in any of the programs you want to print today's date, then what do? You can just specify dot today, and then this is going to give you today's date, right? Let's see. I just printed it out and see the date has changed. Today's date is 2029/13. This is how the date is getting printed. And tomorrow when you run the same command, then this is going to change to 2029 and 14. Can you separate out year, month, and day from today's date? Yes, that is possible. These are the values that you can use, right? Today.year, today.month, today.day. You can use these, and then this is actually, if when you look at it, it is separating the date components: year, day, sorry, month, and then day. So you can separate them out as well. So what did we learn here in this code snippet, right? We learned how to fetch today's system date, right? This is what is being fetched from the system, right? So whatever date you are seeing here is actually picking that value, right? So this is what is happening here. Let me try and change this to 15. I don't know if this is going to allow me. I may not have admin rights on this. So let's not do this. Let's not worry about this. But then whatever the system date and time is, this is going to pick the date from the system time. Simple. Okay. The way we have functions to work for date, the same way we have functions to work for time as well, right? And the rules of the function are going to be pretty much the same. This is very, uh, similar. So from date and time, what we are trying to import here, instead of date, we are trying to import time. And now time will have again the same components, right? How do we define time? Use the function time, and then you will have hour, minute, and seconds, right? And this is what is happening here. I'm specifying a time which has a value of 13, which means 1 p.m., 24 minutes, and 56 seconds, right? So this is going to be the time which I have just defined. Uh, Again, these arguments needs to be within the range. So this value cannot be more than 24, right? This value cannot be more than, the minute value cannot be more than 60, and then the second value cannot be more than 60. The hour value cannot be more than 24, right? This is going to be in the 24-hour format. So this is how you actually define your time as well. There are ways where we can actually only specify specific parameters. That is also possible. So let's say I only want to specify minute. I do not want to specify hour and seconds value. Then can I do this? Yes, you can do this. You can specify minute is equal to 12. And then when I do this, then see what is happening. The time which is being constructed, it does not have hour. So hour is 0. It does not have seconds. So seconds is 0. Right? Okay. Uh, See what is happening here. My time is equal to time. So did we specify anything in here? No, we did not. There are two ways, right? Either you specify hour, minute, and second, or you specify either of these, right? But then now what are we doing? We are not specifying anything. So we are just defining a time where everything is a zero, which which may be required for you on specific cases, but it does not actually give you any value because we have not specified anything in here. Now the invalid values, right? I'm wanting to specify time, but I want to specify hour is equal to 26. And I already told you that it is not possible. Hour cannot be more than 24, right? And this is what the error message says, right? Hour must be in 0 to 23, right? So 0 to 23 would mean first hour to 24th hour, right? And that is how it is actually giving you the error. Our value should be a valid one. The same ways, what do you think? Will this work or not? 23 specified as a string value. It will not. It will not. And because it requires an integer to work on. And that is why it is going to give you an error. So this is going to not work like we saw earlier. So this is going to be very, similar. And the way, when you look up, for today we found out year, for today we found out month, and for today we found out date. Because we were working with date, the components are year, month, and day. When you're working with time, then you can actually find out hour, minute, second, and microsecond. You can find all of these out. So how can we do this? First, let me define a time, right? So we have specified time as 11th hour, 34th minute, 56 second, and 55 microseconds, right? So this is dividing each second into 100 microseconds, right? So how do we find the different components of time? You can specify hour, minute, seconds, and microsecond, and this is going to give you the different components of time. So hour, minute, second, and microsecond, right? So simple. Either you specify your own time or date, or you pick today's date from the system. That is totally fine. So what we have seen so far are two classes. We have seen time, which is used to store time, and we have seen date, which is used to store date. Now there is a third class which you can use to store both of them simultaneously, and that is called date time. So the function, so the so the class that we are trying to import here is a little different. It is called date time. Very simple. For date you have to use date. For time you have to use time, and for both date and time you have to use date time. As simple as that. Now, how do we use this? You have to just add all the parameters together. First specify the date parameters and then specify the time parameters. So how do we specify a date time, right? See, you can only specify the date part. In that case, if you print the date, then your date will be correct, but your time will be empty. Time will be 0, right? So let me make it a little relevant. 9, and let's say today's date. I did not specify anything for time, so it became 0. But what if I specify, so time is 21, 24, I don't know the seconds, so I'm just taking a guess, 45, and then microseconds, right? So microseconds, I can specify just any value, right? 200 microseconds. So when I do this, then what you see here is the microseconds could be a 6-digit value, right? So see, what is my time right now, or date time right now? 2020, 9, 13, 21 became the hour, then the minute, then the seconds, right? 24, 45, and whatever is you specified afterwards, it became the microseconds. So now what is happening in date time? It is the same as date or time. It's just that you have combined both of them together. First three parameters will be for date. The rest four parameters will be for time. And you can specify all of them together. This is the only benefit of using datetime function. So again, this is on the similar lines. So all the other two rules that I specified, where all of these values needs to be valid values, it will still apply here, and they need to be numerical values. They cannot be string values. So that is also applicable here. Now, there is an interesting function called now, Now. That's something we should look at. So how we can actually use now is uh, today is equal to datetime.now, right? So when you do that and print it, see what is getting printed right now. It is actually printing you both the date and the time of the system right now. When I run this again, just see how this part is going to change. I'm just going to run this again and see the seconds has changed, right? I'm running this again. So second has changed from 32 to 38, right? I'm running this again, and now seconds has changed from 38 to 43, right? So what is this function doing? What is the now function doing? Whenever you run this function, the it is actually fetching the the date and time of that time when the function is running, and it is fetching that from my system clock, right? And then this is going to give you the date and time. You can separate hour, minute, second the way we have seen earlier by using dot hour, dot minute, dot second. However you want, you can actually break this down further. So three things that we have seen so far: date, time, and date time, right? Three functions.